Arc Junkies presents Weld Wednesday with AWS. Brought to you by the American Welding Society. And now your host, Jason Becker.
All right, ladies and gentlemen, welcome to a very special episode of Weld Wednesdays with AWS. This is actually the first in-person, in front of a live studio audience. Joining me today, I have my good buddy Padraic from Lincoln Electric and Charlie Cross from Lincoln Electric. We're going to be talking about WPQRs, WPSs, SWPSs, WPQRTs, pre-WPSs, and all the other acronyms that we've come to know and love when it comes to training, testing, manufacturing, and everything that goes along with welding. So let's go ahead and kick it off. Gents, what's the first document we need to look at when we're developing procedures?
So I think before you get to documentation, one of the steps that gets missed by manufacturers quite a bit is before you start, you want to have an idea of, okay, well, what welding procedures do I need? What do I need to weld together? So generally what we recommend is you start to build a matrix. So this is your first step. You build a matrix of all the different things you need to weld together, all the different material thicknesses, material types, and that's where you start.
And typically you'll look at, code requirements, contract documents, but the PQR matrix is going to tell us, here's a list of the base material dimensions and sizes we need with the joint designs, and it's going to help us get organized for us to then move on to start getting prepared for everything else that we need to physically be out in the lab and get welding.
Now, Charlie, you came up with you do a lot of pre-welding procedure specifications.
So what Jason's referring to is a preliminary weld procedure specification, and in fact, it's one of the things that you have a PQR matrix, and you need to get a little bit organized. We look at things that we would call the big six of a preliminary weld procedure specification, and that would be, the first thing is, what's the process? Or is it GMAW? Is it FCAW, GTAW, SMAW? Number one is the process. And then as soon as we identify the process, the next thing we want to know is, what is the base metal that we're welding? For example, is it ASTM A36? Is it ASTM A572 grade 50? Is it any of the API materials? So what is the base metal? And as soon as we know what the process is, and we know what the base metal is, then we can use documents like a filler metal selector guide that a lot of reputable manufacturers offer. And we can identify what the filler metal needs, which is the third thing. So we have the process, the third thing out of the big six. We have the process, we have the base metal, we have the filler metal. And then once we get to identify the filler metal, for example, if it's shielded metal arc welding, are you using a low hydrogen electrode that has a AWS classification that ends in a 5, 6, or 8 if it's low hydrogen, or is it a non-low hydrogen electrode? We want to identify the thermal conditions. So the fourth thing is the thermal conditions. Those could be different based off the type of welding process or the electrodes, for example, in shielded metal arc welding scenarios. So we've got right now, Jason, we've got four things out of the big six of a preliminary WPS, because we're just trying to get something on paper to get us organized. We've got the process, we've got the base metal, we've been able to then identify the filler metal and thermal conditions, and then we should already have this. It's the joint design based off of the PQR matrix. When you get your material prepped, you're going to most likely get your bevels made, but how you tack that up, that's going to you're going to have you may have some challenges when you prepare the base material for whether it's the root opening or making sure that the bevel angles are appropriately developed. I mean, there's been scenarios where Padraic and we've worked on procedure development before, and the machine shop read the bevel angles completely different than what we prescribed on our PQR data matrix. So now we're at 5 of 6. Process, base metal, filler metal, thermal conditions. We got the joint design. Is it a fillet weld in a T-joint? Is it a V-groove weld in a butt joint? And then finally, Number 6 is really, really important. And this is where a welding professional shines. It's essentially the parameters, the knobs on the machine. What does wire feed speed do? What does voltage do? And how are we going to sequence these welds appropriately? And really, as soon as we get the big 6, process, base metal, filler metal, thermal conditions, joint design, and parameters, then we pretty much have a good identification of what we're going to do out in the lab, and we can share that with the rest of the welding professionals and start gathering data collection.
So, Jason, I know you've probably heard this before, but the idea is plan the work the plan. So before you get out in the shop, have a good idea of how you're going to weld it, what your joint configuration is going to be, like Charlie said. Get all that information together so that when you start collecting data, you're ready to go.
Mm-hmm. That's one of the things I deal with clients a lot. They call up and they say, hey, I want a certified welder. And we start going through, the big 6. What process are you running? I can certify them in SMAW, but if all the work's GMAW, that's not going to make a difference at the end of the day. So I go through the same list with all the different clients. What's the process? What's the joint configuration? What type of material? Because there's no point in selling them something or developing them something that they're not going to be able to use, or they're not going to need at the end of the day. So once we get that preliminary WPS put in place, then we can go out to the lab, like you said, get the material, get it prepped, put the bevel on it, clean your base metal, get it all tacked up, get it in the right configuration, dial everything in as far as the settings. And Charlie, I like what you said earlier. Most of the manufacturers, how many of you are CWIs? So if you are writing procedures, you can actually get a consumables book or a filler metal guide from the electrode manufacturer, and they'll get you pretty close as far as the amperage that you're looking for based off the material thickness. You can start pre-populating that document. You get a really good idea of what needs to go on your preliminary WPS. And then the travel speed, what is it? The Bartonian. I always want to say Bernoulli's Bartonian conversion.
Yeah, the Bartonian conversion factor developed by a guy named Dave Barton, who is a fellow at Westinghouse. At the end of the day, every weld pretty much for arc welding that Padraic, Bean, or myself look at is a 5/16 fillet weld. Because if we understand the parameters of that 5/16 isosceles triangle, then whatever the deposition rate is to create that 5/16 isosceles triangle, whatever the deposition rate is, say it's 10 pounds per hour, well, then your travel speed from point A to point B to create that 5/16 isosceles triangle fillet weld is going to be 10 inches a minute.
It's a 1-to-1 conversion for a 5/16. Whatever your deposition rate is, that's what your travel speed is.
And that's based off wire diameter.
It's based off of deposition rate.
Yeah, the deposition rate with that Bartonian conversion factor.
Parameters, essentially, for like your wire feed speed. In Lincoln Electric's Inner Shield Welding Guide on page 42 is an excellent resource, because people will say, well, show me some documentation that has that. Well, in our literature, we actually have it. The Inner Shield Welding Guide, page 42, covers that. We covered that yesterday.
And one of the other things I think to touch on when you get out in the lab, again, that idea, plan the work the plan, is start to have your tools together that you're going to use to collect your data. Because right off the bat, you're going to be measuring preheat before you start welding your test plates. So you're going to need to start collecting data right off the bat. Are we going to have somebody that's watching the screen and the readout, keeping track of amperage and voltage? Are we using some digital form of data collection? For example, if you have like a power wave, for example, you can use Power Wave Manager, and it will take real-time data for you that you can then put onto your PQR. Or do you use an arc tracker, which is another piece of Lincoln equipment, so you can use Power Wave Manager? Either way, you have to have a plan to start collecting that data.
Yeah, by the time the weld's over, it's too late to start collecting data. You need real-time information feedback. So if you're developing these processes, procedures, it sometimes can take up to 2 people. You got one person performing the weld, one person collecting all the data, filling in all the parameters of the WPS or the preliminary WPS.
Yeah, and one of the most important things to stress when we talked about the preliminary WPS is you might encounter people that may not have to fabricate to code requires specifications. But so the preliminary WPS, at least if it's documented, if they're not working to a code, at least they would have something as a measurable baseline. So if they do want to focus on operational and financial performance or any improvements, they at least have a baseline of what they've been working on, and what gets measured gets managed, so they can then manage that baseline. And then the other thing is, too, even if people don't work the codes, if they have that documented, one of the things that Jason and Patty, we've done before with preliminary WPSs is we're going to validate those a lot of times, so we at least know what's going on inside the weld. So,
and when Charlie talks about validation, this is something that we even use for pre-qualified WPSs, and depending on what codes you work to, the variables that make a welding procedure pre-qualified are different. So you have to be very in tune with which code you're working to. But we use validation, and in general, validation is not talked about in the codes. It's for pre-qualified WPSs. But what they do say, most codes, is that at the end of the day, it's the fabricator's responsibility to ensure that they are putting out quality welds. So I think the best thing to do, even if you're running a pre-qualified WPS, is even as simple as do a fillet weld break test. Cut a macro. Doesn't have to be anything crazy. I mean, a fillet weld break and a macro, you can do that in your garage at home.
And it's going to tell you a lot of information.
Yeah, it doesn't even matter if you're qualifying a procedure. What if you are a welder who builds products out of the garage? Don't you want to have some idea that what you're doing is effective? So like I said, fillet weld break. You can do that on a table with a vise and a hammer. You can cut a macro and you can use navel jelly to etch it on carbon steel. It's nothing crazy.
Or Works toilet bowl cleaner.
Works toilet bowl cleaner.
In a pinch.
I used to run a side business, cleaning and maintaining draft beer systems. So the acid cleaner for a draft beer system works great for etching carbon steel.
If need be, if you're doing a lot of testing and stuff like that, you need faster results. You can go down to your local welding supplier, and you can get like a 2% nitol, or they actually make a D12 solution for all of your aluminum.
There you go.
It's a very specific solution. Same thing with they do one for stainless steel. There's different acids for whatever material you're going to be doing your macros on.
So kind of getting back to the process of what we're doing when we're going to qualify a WPS. Now that we have our preliminary WPS, now we need to go out. We need to start welding our test plates, right? And the process you use is going to be different depending on the joint configuration. If we're doing multi-pass groove welds, we need to be prepared to collect data per pass. Again, what is the heat of the plate before for preheat? What's our inner pass temperatures? If we're just doing a fillet weld, if it's single pass, you may not be as worried about inner pass temperature because you're only making one pass. But you need to be ready to start collecting all that data and putting it onto your PQR. And this is where you really have to understand the code that you're working to, because those variables that you have to collect may change depending on the code. Or if, say, you have impact testing requirements, you're using your piece is going to be operating at low temperatures. You may want to have impact testing results. So heat input is going to be very important. So now it's time to start collecting that data. And it's important to remember when you do a PQR, we don't put ranges on a PQR. That's the procedure qualification record. That is the record of exactly what we did when we were welding.
It's a snapshot in time of this is exactly what took place. The exact amount of amps, volts, wire feed speed, travel speed, gas composition, flow, all that stuff.
All of that stuff. And again, depending on which code you're working to, those things may change. You want to have a copy of that document sitting right in front of you so you check all those boxes. The goal of writing welding procedures for your welding program, if you are fabricating to a code, is I teach people to try to be audit proof. And the best way to do that is to just follow the book. Number 1, number 2, number 3 for essential variables, and check all the boxes.
Yeah, a lot of codes, standards, and specifications, they'll essentially have a table that says these are the essential variables that you need to follow. And it's funny. Sometimes I talk to people and they'll say, well, we need to follow the essential variables. And I'll say, what's the code or what's the contract documents require? And so they'll have a list of things in the code, and then they may even have, which would be a table. And as Patty said, you'll literally put a check mark and make sure that everything is addressed to make sure that weld metal meets the base metal requirements on a procedure qualification record, the PQR. And as our good friend Walt Spurko says, we're not one of the things too people get confused about when they talk about welding records is there's a difference between the paper and the human. Right now, the PQR, we're talking about the recipe, the original documentation, as Patty said, that we're going to collect the data of exactly what we did when we performed the test to make sure that the weld metal meets the base metal requirements of the code standard or specification, and contract documents. So there may also be contract documents. I know for a fact that Patty's worked on several projects in the past where he had contract documents that trumped the code books. Because folks, at the end of the day, code books are essentially history books, and codes always seem to lag industry. Industry is moving so fast. We're at FabTech 2023, and it's just incredible to see the passion and excitement of all these different technologies being showcased at this event. But when we think about code books, one of the things we do need to keep in mind is that.
Yep, I think that's an incredibly good point, because when you're doing that PQR, you got to remember that your list of essential variables, the things on that list are the minimum requirement to record. So, for example, what happens if we are going to qualify a procedure with pulsed MIG, right? So you have your standard, maybe you have amperage, you've got wire feed speed. Some codes only require one of those. So you may decide that, hey, I actually want to have both. I actually prefer doing that, honestly, because I look at it as input-output. The welder is going to input the wire feed speed to set the machine, and the inspector, when they come around to do their spot checks, make sure everything's going to plan, they have the amperage to look out. So you may decide that, hey, I know it only says I need one. In some cases, I want to put both. Or if you're running pulse MIG, maybe you want to put your trim value. If it's trim controlled, trim is a little bit different than voltage. Even if the code doesn't say to put trim on there, you might want to put it on there. If you have a setting that allows you to refine the arc, I know Lincoln has secondary settings or background settings, Ultimark, for example, that allow you to narrow and widen the arc to really fine tune it. If the document doesn't say that you have to put it on there, you still may want to record that so that the welder can input that information and get the same result that you got when you tested it.
Right. You can't have too many details on the WPS. It starts getting confusing. But if I want a welder to make the same repeatable welds every single time, and I only list the amperage value for a process like gas metal arc welding, they're going to be out there just twisting knobs trying to figure out I'm not getting the right amperage. But if I tell you, hey, you need to be in between 350 to 375 inches a minute, and ideally that should yield X amount of amps, the welder can actually walk out there, set the wire feed speed, set his voltage, boom, start welding, check the machine, make sure he's getting the appropriate amperage. If he's not, he can go up or down from there. But at least gives them a range, because at the end of the day, you want this stuff to be as fast and efficient for the welders to get the work done. It's all about productivity.
The WPS is my time as a welding professional to explain to the welder exactly what they have to do to get the same result again, or a similar result that we did in testing.
It's all about repeatability.
That's it. And I don't want to have to go down to the shop floor and individually explain to 100 welders, oh, by the way, I know the WPS says this, but if you really want to get there, make this adjustment, make that adjustment. I want it all to be on there. It tells the story. It makes it easy for the welder. Because the time that they spend trying to interpret your documentation is time that they're not welding. We're paying people to be on the shop floor, to weld, to build product. We don't want them taking their time to interpret welding documentation.
Right. And like Charlie said, a lot of times your engineer on record or the contract documents, that can be a little bit more strict or a little bit more loose based off of, what the job requirements are. So, reading the contract documents, everything that comes along with it, making sure that you're following within those parameters. Because you at the end of the day, you can say, hey, this meets code. And the contractor is going to say, I don't care. This is what our requirements are. The engineer on record said that here's how we're going to do it. These are the variables we need listed.
So once we record all those variables, and again, depending on what you're doing, the amount of data that you're going to record can vary significantly. Now we need to get to our testing part, right?
Yeah. So from the PQR stand, from the procedure qualification record, in order to qualify a procedure, one of the things that we want to make sure we do, and keep in mind, visual inspection is one of the most powerful tools. I love telling welding professionals, you're your own best welding inspector. And, you should be aware of, the four components of visual inspection. flat face, proper placement, fairly uniform, and good wash-in. But aside of visual inspection, we get into, the code standard spec contract documents may take you to do several, different non-destructive testing methods. And we're still on the procedure qualification record. So we've spent all this time with a welding professional. Sometimes we even have a data collection individual there. We've been in the lab. We welded out our plate. We did some visual inspection on it to meet the code standard spec or even contract document requirements. And just imagine you have this plate, you have all this time into this plate, data record, documentation on this. You took the time to weld this plate. And as Patty said, we still have to go get, a lot of times based off the code standard spec, non-destructive examination, which could be aside of visual inspection, we could have penetrant testing, mag particle testing, we could have radiographic testing or ultrasonic testing. A lot of code standard specs will say, radiographic testing or ultrasonic testing, and then if that passes, let's move on down to the mechanicals, where we're going to cut that test plate out or pipe, and we're going to actually cut bends, tensils, we may cut CVNs, we may even have to do a hardness test on the material. So depending on the code standard or spec, if you do all that work and it may even pass the non-destructive examination, but it still may not even pass the mechanicals, then you have to go back to the drawing board again. And you're not ready to move on and develop a weld procedure specification yet, because you don't have the validation that the weld metal meets the base metal requirements.
But then you take that data, let's say you didn't pass, let's say you failed one of those areas. Now that you have the data, because we tracked everything, developing the pre-WPS, we can go back there from that snapshot in time that we took and say, oh, we got porosity. Okay, that could be a gas issue. Okay, we're failing our Sharpies. That's probably a heat input issue. So maybe we need to speed up the travel speed, get the amps in a little bit quicker and move faster across the plate. Or, okay, we got trapped slag in there. Okay, we didn't do proper interpass cleaning. So that actually the results of those tests, they're going to tell you what variables you need to go back and look at and redial it in. So you're not going back and kind of rewriting the entire pre-WPS. You got a good snapshot as to where to look with that data that's given. And then you can make your adjustments from there, rerun that plate again.
And it's important to remember that at the point when you've gotten to this point, especially, for example, if we're doing a complete joint penetration groove weld, if there's a call out for Sharpie V-notch testing for toughness, if there is a call out for volumetric inspection, for mechanical testing, you have to imagine the amount of money and time you have put into this test plate at this point. This is where I can't stress enough that a little bit of pre-validation can really save you in the long run. Because if I do a groove weld test and I just go ahead, before I go through the whole process of doing my mechanical testing, non-destructive, whatever, if for a validation I weld out a groove weld and I cut it and I do some macros, you may find porosity. You may find some inclusions. You may find some of these issues. Maybe, I did a macro and I saw some incomplete fusion. You can address that stuff before you get to your actual PQR plate, and you can save yourself a ton of money. I can't stress enough how much validation can save you.
So now let's say it does pass, Charlie. Where do we go from there? We have we got our preliminary WPS. We got our PQR that we developed. It passed all the different mechanical testing, visual testing, everything. Where do we go from there?
So typically, the PQR procedure qualification record, it passes. We keep it locked up in our scenario as in a file cabinet, or we keep the PQR locked away, because that is the peer validation that we've done homework to meet the code and contract requirements. Now we're ready to make a weld procedure specification based off of that we would share with the welding professionals that are doing fabrication. So what we would do essentially is we would use the PQR variables, and we would look at a code standard or spec, and we would take the data almost like citing a source. Like, you might quote some statements from our good friend Ryan Eubank and some good quotes that he has. you're essentially doing the same thing. You're going to cite the source, for example, the procedure qualification record that validated the weld metal met the base metal requirements with maybe the GMAW process, pulse spray transfer with a 035 diameter electrode at this wire feed speed, at this voltage level, and you'll take that data, and then what you'll end up doing is you can be as specific as you want on the weld procedure specification, because we have to remember when we're fabricating to a code standard spec contract documents, I like to say we're not an art class. Look, we're working on very serious things, and most individuals that work to code standards and specs, the least expensive weld is only made once. And we want to keep that in mind. We want to do things in accordance. So we're not an art class. We don't get to play with the knobs and do what we want to do. The WPS is the clear direction on how we're supposed to weld the specimen and how we're also supposed to, clean the specimen, thermal conditions, and the parameters. And at the end of the day, if you incorporate that, once again, you have your measurable for production, so you can identify what your throughput, or get some good estimates or values on how you measure your throughput using that measurable.
Yep, and that's the document. Again, that's a document that tells the welder the recipe. So you take your PQR. Now you're going to go through the list of qualification ranges, right? So, for example, you may run into a scenario, depending on the code or standard. Maybe you qualified and you welded out a half-inch plate for your PQR. But for a WPS, depending on the range of qualification, you may be able to weld material that's twice as thick or maybe half as thick. If you qualified on a complete joint penetration groove weld, you may be able to use that PQR to write a WPS for a fillet weld. So this is where you look at those qualification ranges. And in a lot of cases, you can write a catalog of WPSs off of one PQR. So it's important, especially, again, we talked about the amount of money it takes to develop a PQR. Make sure you're getting your bang for your buck, right? Make sure you're qualifying your procedures that are going to give you the most leeway to write WPSs. Now, on the flip side, I will say that one of the things I see quite a bit in the industry is a lot of people always revert back to the CJP groove weld for PQRs. The number of people out there, the number of fabricators out there that are really only
actually doing it.
They're only welding fillet welds, and they're spending all that money on a CJP groove weld PQR. It's staggering. There are a lot of codes that allow you to weld out a fillet weld, maybe single pass on one side, multi-pass on the other, largest single pass, smallest multi-pass. Cut 3 macros, and that's your PQR. So make sure you're getting the most bang for your buck. Follow the code, and don't necessarily get wrapped into the idea that I always have to do groove welds.
And that's what I try to educate people with too, because there's no point selling your client or developing it for your company things that you don't need. Like you said, it takes a lot of money to develop that stuff. So if everybody out on my shop floor is just running fillet welds 99% of the time, there's no point to go through all of the cost, time, and effort to develop a welding procedure for a complete joint penetration weld. Same thing when you're certifying welders. You don't need to certify them for everything if that's all they're going to be doing.
Yeah, if I only need a welder to be able to weld fillet welds in all positions, what's the benefit of putting them through the battery of tests necessary to get an all-position qualification for groove welds? It's just so much more work.
Well, yeah, you'd have to qualify the groove plate, and then you'd probably have to do some validation on the fillet weld and a T-joint test plate. So it's double work, essentially, in that manner.
So in addition to the range of qualifications, once we get that PQR, then we can take that PQR and we can start adding our different tolerances in. So based off of what's considered an essential variable, you can pull the table up in the applicable code book or the contract documents. Now I can say I can have plus or minus a percentage of voltage that we actually use. So if, let's say we use 20% voltage on our PQR, we get a plus or minus value on that. Same thing with our amperage, wire feed speed, and travel speed. That gives the welder a little bit more room to work with. I know when I did jobs, when I was doing structural steel ironwork, the D11 code said I could have plus or minus 10%, but the contract document said I could have plus or minus 4 amps. Like, I mean, they had it isolated down that small. I can only have plus or minus 4 amps on that weld, and it was monitored every single pass.
There are some codes out there, and this is when you're writing that WPS and you start to apply ranges. Remember, those ranges that they give you in the code are the maximum allowable ranges that you can put on your document. That's where it's really important to start exercising some of that technical knowledge, that technical expertise. You know, for example, there are some codes out there that I've seen that allow up to a 25% swing in amperage. And they also allow for a voltage variance. You may get into a situation where if you take advantage of that full range for both amperage and voltage, you now have a procedure that doesn't work. So it's important to keep that in mind, that you have to exercise some judgment when you start applying your ranges so that it's actually workable when it gets out to the shop floor. Because the first thing the welder's going to say when that weld fails is, hey, I followed the WPS.
So one of the things, too, that I've seen, you might see people that are fairly new getting in the game of welding records and documentations, and they may see a form that looks really pretty, and they want to keep the same form for all the welding. And this may be a facility that does all different types of welding at their facility. And this form is established. The one we need to keep in mind, as a friend of mine, Frank Draglich, mentions, a WPS could be written on a napkin as long as it meets the requirements of the code standards or specs. And, you know, a good conversation, you know, I get to work with a lot of really smart welding professionals, Teresa Melfi, Kevin Beardsley, Jason Schmidt, Rob Kaminsky, Patty and I, we get to work with these folks, and we see a lot of really good, they're really attractive looking documents. And, you know, one of the things we like to look at is we'll have the code book, and that's what the meat and potatoes at the minimum requirements that we're trying to hit. You know, just because something has something on the document, we want to make sure that the minimum requirements of the code are addressed. So sometimes people forget those items, and we just want to make sure that we hit the requirements of the code standard, spec, and contract documents. There may be a pre-processed form where they may have a category on that pre-processed procedure document, and it really has no relevance to the specific job that you're doing.
Yeah. And I will say, you know, especially a lot of AWS codes, you know, for newer people getting into it, if you want to have a form or a template that you can follow that makes sense, is laid out in a fairly organized manner, a lot of those code books will have sample forms. That is a great place to start. You know, whether it's D11, D16, D13, you'll find annexes in the back of a lot of these AWS codes that give you a sample form. It's a great place to start. You just have to make sure that it really checks all the boxes. What's
better than that is actually if you go to aws.org, you can click on they got a whole list of resources, and you can download these forms that, you know, the annex forms that are in the back of the book. You can download them and then populate them right there in your PDF editor.
Yep, there you go.
And it makes it super simple. So now, go ahead, Charlie.
So one of the things, too, while we're on this topic, AWS B2.1 is getting a lot of attention too, and that's been one of the best kept secrets. So say you are working to some of these AWS code standards or specs, and you know you're working on something that may not fit in the perfect box that meets that code requirements. The engineer of record for a lot of these codes, D11 or you know D13, any of these codes, B2.1 may be an opportunity for folks to investigate. And there's been a lot of training programs around it, like the WPQ1, WPQ2 endorsements for professional development.
You know, there's a large portion of the industry that does not necessarily weld to a specific code or standard. But that doesn't mean that they don't want to have control of their program and don't want to put out quality products. Just because you don't have a contract spec that forces you to weld to a code or standard, you still may want to be able to track your quality. Make sure you're putting down quality welds. And to Charlie's point, the B2.1, whether or not you weld to a code or standard, is a great roadmap to qualify procedures and then qualify personnel to weld with those welding procedures, regardless of your contract requirements.
So Jason, we talked about this thus far, this journey that we've been expanding on. We started with a preliminary WPS that covered the process, base metal, filler metal, thermal conditions, joint design, and parameters. Then we went into the shop and we welded the procedure qualification record, the PQR, that had the exact values of what we did. A lot of times, one of the interesting things is data collecting that digitally. And that plate passed the test. We wrote several WPSs, weld procedure specifications, off of that, some that may have ranges, some that may be very specific, but they're cited on the WPS. You would see a reference of the PQR that was derived from, cited from. Then the next step that we can go to is a really exciting step, is the weld performance qualification. You might see it as a WPQ. You might see it as a WQTR, welder qualification test record. But at the end of the day, we've done, as our friend Walt Spurko says, there's the wall between the procedure, the documentation, and now there's on to the performance, which is the human. And when you look through code standard specifications, one of the things to keep your eyes honed in on is the difference between the word procedure and performance. Conversations, people, I think Jason told some stories recently, when he gets phone calls, is people need to be qualified. It's really hard. I don't understand how people can be a qualified welder without a qualified procedure.
Yeah, what are they qualified to? What are they certified to? They got to be certified to that WPS, which is developed from that PQR.
Yeah, to a code standard or spec that
exactly.
That
there should be a whole
documents.
There should be a whole paper trail. If you're going to go in and test or certify a welder, you got to test them to something very specific. So you're testing them to that WPS, which is backed by a PQR or possibly an SWPS through the American Welding Society. You've got to show like you've done your due diligence.
Yeah, that's a good point too. When we at Lincoln Electric, we started our accredited testing facility, we utilized the American Welding Society's AWS B2.1 SWPSs, standard weld procedure specifications. They can be purchased through the AWS bookstore, and they were really helpful for us to essentially get started from a testing perspective. But while we're on to the human, the performance, and that's where you'll see a lot of accredited testing facilities coming up. But people are going to get qualified through to a process under a code, in accordance with a code standard or specification.
Yep, and the ranges for that person's qualification. So that test that you might take, you've qualified your welding procedure, you hand it to the welder, they're going to do their welder performance qualification test. They follow the WPS that you gave them, and now the welder, in a lot of cases, has some ranges of qualification, just like our welding procedure did. So you may weld in the horizontal position, for example, and some codes may say, okay, now that you took that test in the horizontal, you can weld horizontal and flat, or you have welded overhead, and now you can weld overhead, flat, and horizontal. So same thing as doing your PQR, your WPS. You have to follow the list, check all the boxes, understand your ranges of qualification. Now, the company, again, does have some leeway, though. You may decide that, hey, if I qualified you in overhead, you are only qualified for overhead. Just because the code gives you a range that you're working to, the company always has the right to make things more stringent.
Yeah, they just can't be more relaxed. You got to meet the bare minimum, but they can also dial in those parameters. One other important thing to kind of bring up and mention is the fact that if Charlie and Patty and I go out into the shop and I'm logging all the data and Charlie's taking care of all the document and Patty's doing the welding, once he welds out that WPS test plate, we send it off and get it tested, develop that PQR from it. I don't need to go out and test Patty again, because he welded that original test plate that passed and met all the requirements. So now he's actually certified to do that document. So if you just have one welder in your shop, you can go ahead and test him. He can be certified while they're making that test plate. But if you got a couple folks out in the shop, now you've already tested one welder. Okay, that's a cost you don't have to incur anymore. Now you can go out and test the other 3 or 4 welders or the entire shop to that same WPS.
Yep. I always say it, whatever documentation you're doing, take it step by step. It's a lot of information, and it can look really overwhelming, right? But we need to really narrow it down and just pick each piece of information that we want. Check all the boxes for WPSs, PQRs, welder performance qualification tests. Check all the boxes, and by the time you're done, you'll step back and you'll see this document that has all the information on it. It's all filled out correctly, and then at that point, like I say, this idea of making your program audit-proof. You've checked all the boxes. Now, if you are, say, fabricating to a coder standard, or you have a customer that wants to come in and also review your documentation, now confidently you can hand that to them. And you can say, yep, the code says this, and we got this, and this. You go down through the list, and now your customer's happy.
Right.
So kind of summarizing that, one of the things we want to look at is, did the customer, or the individual or company, the first question to us as welding professionals is, are we fabricating to a code or fabricating a code standard spec or contract documents, or not to a code? If it's not to a code, maybe the question's why, but, maybe we can develop a preliminary weld procedure specification and at least have a baseline to get going and do some validation before we get into producing the element that we're our product. If we are fabricating to a code, as the steps we talked about is, we developed our PQR data matrix. We developed a preliminary WPS. We went out into the lab and we had a test plate that was tacked up, and we welded the procedure qualification, and we documented that. So a procedure qualification record was developed after testing. After that, we wrote multiple WPSs, or just one, based upon that procedure qualification record, PQR. And then we moved on. We were able to then give the welding professional the WPS. They were able to weld to a specific test in accordance to that code standard spec to a process. And they became qualified to that process under that code, and now they're ready to fabricate to a code. So there's kind of some steps to follow.
Yep. And there's nothing worse than Charlie and I do a lot of consultation for companies out there, and some of the questions that we ask are, do you have welding procedures? Are they any good? Do your welders use them? And there's nothing worse than when, yes, they do have welding procedures. And man, after we review them, they're actually really good. But they don't give their welders access to them, or the welders don't use them. They have no mechanism to monitor their use in production. So you really have to check all those boxes. Have good WPSs, good written records, and make sure people have access to them.
Yeah. I know it's going to be a good day when I go into a company and I ask those three questions, and it's yes, yes, and yes. Oh, this is going to make my life so much easier. And it's like finding a needle in a haystack. Very few times you walk into a company and say, do you all have a WPS? And they're, yeah, we have WPSs. Okay. Do your welders have access to them? Yes. Do they use them? Yes. Can I see them? You look them over and you're like, okay, these are well written. But the majority of the time I get, what's a WPS? And okay, all right, we need to start here. Before we go and certify everybody, bring your welders around the table. We need to have a quick conversation about how we're going to do this.
Or back in 1985, we had a guy that worked there, and I think he had a book of WPSs. Let me see if I can dig those out.
And one of the things we want to do, with Patty and Jason here on this podcast is, and myself, we want this. This should be something that's encouraging for people to get into, and we just really see it very beneficial to moving the welding industry forward, and companies and welding professionals should be encouraged to investigate and focus and hone in on their skills when it comes to welding records.
Like Charlie said, AWS has some great resources to learn more about welding procedures, welding records. Lincoln Electric, offers some resources to learn about the same thing. Charlie used to teach our welding procedure development seminar. I've since taken that over. We've got another one coming up in Rochester in October. Go out, get training. Learn from people. That's what Charlie and I did. We didn't just learn this stuff on our own. We were lucky enough to work with people who understood it and were willing to take us under their wing, teach us how to do this properly. I suggest everybody do that. Invest in yourself.
Yeah, and that, I mean, I can attest to that. It was a great class. I went up there and took it. Charlie said he was putting a class on. I said, I'm not missing that one. I took the one up in Atlanta, Georgia, and it was a fantastic class. Because no matter how much you think you know, you're always going to learn something. So I mean, I encourage people to go to seminars and conferences, learn that stuff. We'll go ahead and take a moment right now to open the floor up for any questions. If anybody in the audience has a question, go ahead. This mic right up here is live.
How can we get more instructors and educators to start using WPSs and PQRs in their program so that the new welders coming in the industry at least are familiar with what they're looking at?
I think that is a phenomenally good question. I'll give you an example, and I'm not saying this is one size fits all, right? But I will give you an example of something that I worked on with a local school up in Plattsburgh, New York. So they had some money, and the instructor, who I had worked with quite a bit, had said, we really want to get welders used to documentation. So what they did is they bought a very cheap microscope online, and they actually had, as a capstone project, they had their senior welders develop a fillet weld PQR and WPS. So the welders have to go out, they write the preliminary welding procedure, they go out, they weld the test plate, they cut it, they did the macros, so they bought a little desktop etch booth. They etched the samples, they put them under the microscope, developed all the documentation. I mean, really the best way to get used to those documents is to understand how they're put together. And that was a great little capstone project. He was able to secure all of the equipment to do it for fairly short money. And he's been doing that for 2 years now. And I've actually seen from the manufacturers in that area who are bringing in a lot of his students, they're incredibly impressed with the fact that these students not only understand what the document is, but they have an idea of how it was developed. So that is a great way you can start to introduce students to these documents.
Yeah, and another thing I'd encourage schools, tech centers, training facilities to investigate is essentially the AWS B2.1 document. The American Welding Society does have training courses that revolve around this, and for the instructor, but also, I mean, think about when you go to visit the numerous welding training centers. There's essentially a booth, and somebody will weld coupons, right? Sometimes you will see facilities that have project-based learning activities, but they still get the fundamentals welding on these pre-cut coupons. And if we could just install and utilize the capabilities of AWS B2.1 that can qualify procedures and humans, it's not going to necessarily tell you how to design. It's not going to necessarily tell you how to fabricate and tell you how to fabricate something like for example, an AWS D1.1. But at least B2.1 would give you a baseline on the process of, for example, how do you do a fillet weld break test? Or how do you do some macro etchings for these fillet welds that we're doing? And it's something that can be executed at a very low cost, like Patty said, and give them a professional baseline that's dedicated with measurable results.
I think the last thing that I might recommend is, not every welding instructor is a CWI and has training in how to put these documents together. The AWS SWPSs that they can purchase, it's a great opportunity for them to purchase an SWPS, at least that way, and this is for the most common stuff, right? I mean, so many welders and weld schools out there in the country are welding, V-grooves with a backer on 3/8 plate. You can purchase an SWPS that covers that joint configuration. And now instead of just having the welders pick their settings, they can actually follow an SWPS.
I think what Adam was asking, correct me if I'm wrong, how do we get more instructors to start doing this? So AWS has a lot of great resources. If you get involved with your local section, as an instructor, you can apply for a scholarship. You can take those scholarship dollars, instructor scholarship dollars, and you can apply them to some of the AWS online courses. You can go up and take Charlie Cross and Patty's class at Lincoln. You can go to the Advanced Welding Educator workshops up in Lincoln. There's a lot of resources out there, but as a young instructor, they don't know about that. They come right out of the field. They don't know a whole lot about AWS. They've probably never worked with WPSs. So those are some of the resources that you can start to accumulate. That's the exact path that I went on. I started applying for grants and scholarships and taking different classes around the country, and I'd come back and regurgitate that information to my students. And that's how we started using WPSs when I was in school. or when I was teaching. We'd build WPSs, and then I'd certify the welders to the WPSs right there in the classroom. Show the students, hey, this is a WPS. Show them exactly how to use it step by step. Here's the information that should be on here. Here's your essential variables. Here's your non-essential variables. But there's a lot of different classes out there that people can take all around the U.S. And if you can't get out, because I know a lot of schools have a tight budget, so you can't get out and do the training in person, there's a lot of online resources. Like I mentioned, AWS has the entire AWS Learning Online platform. You can learn all about WPSs, PQRs. Heck, I think there's a module in there that's pretty much very similar to the same title as this episode, Demystifying the Acronyms of AWS. So you can hop on there, and it's going to kind of run you through it and give you a good idea on how to work through some of this documentation.
Well, and, I think the last thing, for a brand new instructor, okay, you've never done this. What is a WPS? What's a PQR? Where's the first place you're going to go to start trying to decipher all this? YouTube, right? So one of the things that I really, really appreciate, from some of our welding professionals out there who have a platform and have a presence on social media, Jason, yourself, the gentleman that, Adam, you asked the question, you put out videos on YouTube and you've discussed documentation. Whether it's, the ARC stars for AWS, Nate Bowman, like these people that are out there in the profession are starting to put out great information online that's free, that discusses a lot of this stuff. So that is one of the greatest things that I see is that, it's really, these welding professionals that have this platform that are really putting out really good information and letting people understand how important it is.
We had a session yesterday, weld engineering for the non-engineer. Engineers are welcome too, but Nate was in there and he played his hyperfill video on qualification. And so many people were like, that was such a well put through video that was done in about 5 minutes. And, keeping people's attention span when these things are developed is really, really a good thing. But at the end of the day, welding records, they may not be the most exciting thing for people, but at the end of the day, it's really helpful once you get things going versus having people turn the knobs and have the paint markers on the knobs on the welding machine. And it really helps people understand what the knobs on the welding machine actually do.
Yeah. Well, this time we're going to close out the episode. I want to thank all y'all for coming. We really appreciate it. Thank you to Padraic Bean and Charlie Cross. I don't know if you guys are available after this session to answer any additional questions, but I appreciate you guys coming out. Thanks for listening to Weld Wednesdays with AWS.